That's where we're going. So we should be able to read a word problem, draw the inequalities. If there's a word problem, right, our graph can look two different ways, right? All four quadrants, right? Or just quadrant one if it's a word problem, right? And then we're just restricted to that. This is no context, right? You don't necessarily need to write this down. I just want to give you a little bit of an overview. It looks kind of messy if you ask me, right? But we went text, inequalities, we graphed it. Because it's a word problem, we stuck to the first quadrant. Then from time to time, I would ask you to state a solution, which is just pick a point from the solution region. And today we're gonna start talking about the best solution, the best out of all those points of intersections, right? And so that's where we're going. That's the last piece of this unit. And so after today, you get a break from an AC today, right? But after today, I'm basically gonna AC you every day until the test on a question like this. So I'm gonna throw different scenarios at you, different examples, so you can keep practicing these sequence of events, right? I want to mention that, I don't know if you can see it on that board over there. Our test is scheduled for next Monday, March. Did I say March 6th? That can't be right. Oops. Yeah, that's not it. I'm living in the past. Move on, right? So what's next Monday? Is it the 14th? It's the 14th. Yeah, it's the 14th. What was I saying? They're like, yes, you wrote it already. It's done, right? Yeah, so the reason, like, yeah, we've been, I've shown you how to just graph, right? No context. We did all that, points of intersection, took a step back, word problems, such as write our inequalities. We did that, and then I said, okay, let's write the inequalities, then graph them, quadrant one only. And now we're gonna go from A solution to B solution, and I'll show you how that's done. So really, nothing new, right? It's just how do you get the full marks if I asked you for something where it's asking how would you get the best outcome? And so that's that. So mark your calendars for the 14th. And I said quiz. I said Tuesday, didn't I? It did say Tuesday. And Wednesday we have our track and field people gone, right? Is it this Wednesday? Yes. So tomorrow's quiz will not include what you're learning today, right? But what we're doing today is still going to help you review, right? Because I'm not really teaching anything new. Like these steps right here, I'm going to be a little bit faster today, and it's just that last step where I'm going to focus in a bit more. But you're going to see them all, so it is a review, right? So we'll write our quiz tomorrow as scheduled, and then our test on the 14th, all right? Okay, so get your notes ready, and we will start. All right. So again, if you show up every day, if you write down the notes, if you do the work, right, when I assign, you take the time, you review your notes, you update your study sheet, you do the homework, you ask questions if you have any, that is your part. That's in your court. If you struggle, if you need help, I more than gladly will help you. I'll be there and help you get through it if you're struggling. But just don't give up though, right? We don't want to give up. We don't want to get to that point where we are so frustrated that we just, I can't do this. I'm just gonna fail. I don't want you to be at that point, right? Which I I don't suspect it will happen, but I don't want you to get there regardless. All right. So here we go. Optimization questions, right? The best answer. Okay, so far we were able to graph the solution set for a system of IQs, right? And stated the resulting POIs surrounding the solution region or polygon. Like sometimes you might come across a worksheet that refers to it as the solution polygon, same thing. Next, if the question asks for a combination XY, that is, right? That will either minimize or maximize the total output it is essentially asking you to find run-on sentences, right? I would not do very well in English. To find the best option from the POIs. So it's gonna, your answer is gonna come from the POIs, the points of intersection that you have determined. Okay, that's why I always asked you to find them, because I wanted you to practice that already using your calculator and all that, right? To determine, I need like steel reinforced lead on my pencil. I break them all the time. To determine the optimal solution, best answer. To optimize something is to make it as good as possible, right? If you want to optimize something, you want to try to find a way to make it smooth. Optimize a program if you're into computer programming, right? You want to make it as smooth as possible. Okay. To determine that, we need an objective, I'm capitalizing it so it sticks out, objective function. Plugging the POIs into the objective function. I'm just going to go OF from now on, okay? I will allow to determine the combination that is the best. I will say this, note, the objective function is not an inequality and should not be graphed. Do not graph the objective function. So let's, I'm just going to give you just a quick diagram here. If you can try to graph this as best as you can. So we're just going to stick to quadrant 1 here. I don't know if you remember the homework. If you did the homework, there was that one question that had the objective function under it. I don't know if you remember that. After today, you should be able to do that. So we have x and y. We happen to just be in quadrant 1. So make one line that kind of goes like this, and another one that is a little higher up the y-axis but cuts it like this. And I'm going to shade above both lines. Okay. So when it's a system, we always shade the false region, right? So the shading is actually not good. So in this case, my solution region would be here, and the corner points surrounding it, we will label them right next to the graph. 4.50. I just made these up, okay? So don't be like, where did he get them from? I'm just making them up. So we have no context for this particular graph. We don't know what x represents. We don't know what y represents. It's just a graph. If the objective function is c is equal to 3x plus 2y, right, comma, determine the combination that will minimize and maximize output. Notice that we want a point that will make it happen, that you get the smallest outcome, and we want a combination that will give you the greatest outcome. So this question is actually asking you to do two things, but it can all be done doing the same steps. And I will do this under the graph if you have room. Okay, so you list, this is how I show it. I list all my points of intersection like this. So I kind of start somewhere and I go clockwise around. And because we don't, like, we're assuming it's continuous because there's a decimal there, right? So you plug that into C, right? C is going to be 3 times 0 plus 2 times 0, which is just 0. We don't know what, but we know it's 0. Then you take your objective function again, and this is 3 times x, which is 0, 2 times y, which is 3. So that obviously gives you 6. And you have c is equal to 3 times 3 plus 2 times 2. And that would be 9, and 4, that's 13. And then I have c is equal to 3 times 4.5 plus 2 times 0. And this is 13.5. So the answer is that, right, this will minimize, a combination of 0, 0 will minimize the outcome, and this will maximize. The question isn't normally going to ask you for both. It's either going to ask you how can you get the maximum out of it, the maximum profit, or how can you minimize cost. Like, it's going to ask you for one of these. But I just decided to ask you for both, right? So 0, 0 will minimize, 4.50 will maximize your output. So, and it was all done by taking the POIs, right? These are, let's put the POIs on top here, like just labeling, right? You take your POIs, you plug it into the objective function, which in this case is provided to us. All we had to do is plug it in. So if you look at the homework question, I'm just going to show you that once. You were also given the objective function, which was like this, and it says determine the combination that would maximize the outcome. Once you find the points of intersection, you just plug it in, and then you figure out which one will give you the most in this case, right? So I will say this next to this. Try page 15, right? 1B. If you want to give that a try, obviously you need to have graphed it and you need to have figured out the POIs already to get that, right? But if you just want to practice without a word problem, then that's where you go. And I'll assign some more later on, okay? All right, now let's dive in and do a word problem. All right, here we go. A parking lot has an area of 540 square meters of space available. You can shorten words, right? If you just want to go avail, right? A car needs 9 square meters of space, comma, while a bus requires 36 meters squared. Okay. The manager of the lot does not want more than 45 vehicles at a time. The lot can have at least 10 cars at a time. Determine the combination. Determine the combination, not a combination. Determine the combination that will maximize profit if cars pay $7.50 and buses $25. And can I, next to profit here, I know I'm gonna go off the script here. Profit is the same thing as revenue. That, because some questions talk about revenue, others talk about profit. So make sure you have revenue next to profits, just to make sure you understand that. Okay, so the first steps are exactly the same as before. So what I want you to focus on today is you want a combination that will maximize profit. Okay, this is an optimization, right? Okay, and okay, I'm gonna tell you already how I'm gonna deal with this. Normally, I will ask you to write an objective function at some point, so you know, right? If I ask you for an objective function, that we're gonna have this. This is an optimization type of scenario. Okay. So let's start with the usual. Let x be something, y be something. So let's come up with that. What can we let x be equal to? What would you say? Not all at once. Cars, okay. And buses. All right. We don't know what yet. Is it number of cars? We're pretty sure it's going to be number of cars. But for now, we're just going to go cars and buses. Then we're going to make sure that Mr. Dirksen doesn't take off half a mark and just letting me know that x and y are both greater than or equal to 0. Okay. All right. Let's come up with inequalities. Where are the inequalities? Let's go back up here. Da-da-da. You see the first restriction? Let's just pick out any restriction that you see here. Right off the bat, the parking lot has an area of 540 square meters, right? You can probably say available, right? What would you say there? What would you replace available with? Maximum up to, right? So I'm just going to go max, right? Just to, and which way is it going to be pointing if it's max? Less than or equal to, right? Okay, so let's write one for that. So space available, we got to use the square meters that are attached with each variable, right? So we can go 9x squared plus 36. Why did I go squared? Sorry. I just taught a lesson before this with squared. Sorry, guys. 9x and 39y has to be less than or equal to 540 square meters, right? So I've got inequality 1 taken care of. And then what's next? I'm going to look through it, and I'm reading, and it says something does not want more, right? Not more than 45 vehicles. How would you write that? Anyone? Can't be Francis because you already answered. Can't be Ben because you already answered. Sorry, Ben. Anyone? Yeah. That's right. We agree, right? All right. X plus y is less than or equal to 45 because now we can kind of assume that it's the number of, right? X and y. It only makes sense. Like if you wrote this has to be number of cars, number of buses. So we'll go number of. So that's our unit, so to speak. It's actually number of cars, number of buses. There's one more in there that I snuck in just before. Actually, my key is totally different now because of that one. Yeah. Bathroom? Okay, go ahead. Go ahead, Ben. X is less than or equal to 10 because you saw this here, right? Okay. At least means that it has to be like that, right? No, it's okay, Ben. Like, I'm serious. Like, that is the more you practice and risk, the more you're going to learn. Okay, so, but do we agree it's that way? Yeah? So we got to go x is greater than or equal to 10. And we love that one. We love these two because they're going to be easy, right? I at least do. So I'm kind of, I don't want to mark too much. So sometimes I just throw in there because they're easy to mark, right? So I'm lazy that way. Anyways, let's answer this one. I'm going to do that right next to it. This is going to be true, a solid line first of all. True is where? The weekend kind of erases everything, right? True is to the right. So we will shade left. It's a system, remember, reverse shading. This one, I'm also going to just do right next to it. But I need to rewrite that one, so I'm actually gonna do that here. So x plus y is less than or equal to 45. So I'm gonna do it again. I just want to have it all in one place. And then I have y is less than or equal to negative x plus 45. I'm going to box that in because it's important when I type that into my calculator. And this is solid. True is below, shade above. Okay, so I'm telling myself where I'm going to shade it. And then I'm also going to do the other one here. 9x plus 36y is less than or equal to 540. And here I'm actually going to show it like this, okay? Because it's important to not jump. I know you just want to get to that graph, but if you make one mistake, it throws everything off. So I suggest you do this. X is equal to 60, 60, 0. Okay. The next one is 36. Y is equal to 540. And sometimes it's a nice round number. And in this case, it is. So I'm kind of rushing through this a little bit because I want to get to the part where I talk about the optimization part. I'm going to rewrite it next here. 36y is less than or equal to negative x plus 540. Divide everything by 36. Y is less than or equal to. Can I do negative 1, 4 here? Is that going to be okay with you? Because 9 goes in there once. 9 goes into 36 4 times. But if you didn't notice that, no harm, right? Like you just leave it. And solid, true is below, shade above. All right. I think I'm gonna take my graph over to another page because I want to have the point of intersections and the objective function. So if you have half a page, you're good. But if it's less than that, I would maybe start a new page if I were you. Okay. So let's graph this. We have 3 inequalities. I'm going to start my graph. Quadrant 1. Okay. So there's my graph, number of cars. Do that right away. Don't leave it for the end, okay? Because you're going to forget. There's that. And I'm looking at my intercepts. If I go to 60 for the x, 60 will do because there's 45 and there's 60. So I'm going to go all the way to 60. So 10, 20, 30, 40, 50, 60. Okay. And the y, it's 45 will do. 45 is the greatest y-intercept. So I'm just going to go 10, 20, 30, 40, and 50. That works for me. Again, you choose. Just have some kind of indication that tells me what you're going up by, and it has to be consistent. So one line at a time here. I'm going to do the 45, 45, because that one is pretty easy. .45 is here on the y-axis, right? Because it's right there. So, and you know what? It's probably a safe assumption to just go off the graph and then just label it here. Okay, that way it's not going to be in your way when you're trying to graph the rest. So then I have the other one, which is 60, 0, 0, 15, which is right there. Oh boy. My label is going to be a bit of a problem, but I think I can manage. So this is 9x plus 36y is less than or equal to 540. And the vertical line, It's just going to go right here. It's going to go right here. I'm just going to, nobody's going to stop me. Stop me, right? It's not there, right? Because a lot of times students mistakenly put it on a horizontal. It's a vertical line, and it's 10, right? You're so busy copying. Don't trick me, Mr. Dirks. Oh. X is greater than or equal to 10. There's an arrowhead on that because it's staying in the first quadrant. Do not go over. From what I've seen, I don't see you extending it past the X and Y axis, so that's good. And I think now we're good to shade. So I'm looking at this one, the 45, 45, right, is above. So we're going to shade that. So just make sure, in this case, it didn't talk specifically to buses, right? It didn't say it can have this many buses. So nothing there, okay? The other line is also shading above. So I take this line and I shade above. So just follow that line and shade everything above it. Okay? So that is all gone. And then the vertical line, we're shading to the left. So then basically it's all of this, right? So far, no surprises. All of this should have been like, yep, 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 I get it. Right, solution goes right there. Let's figure out the POIs. Bless you. The POIs right there. And that's where you come in. So you go find them. I will show you, but I want you to first do it because that's the crucial part today is, can you use your calculator to find those POIs? There are some that you can just read and some you need to find using your calculator. Okay? Question? Okay. Catch. This. If I miss with this one, it can actually knock out a student. Pretty heavy. Okay. I'm going to enter them now. A little slower here. I don't know if you remember the 999, right? Like that to draw a vertical. Your teacher next year may or may not use that, so just go with whatever they're using. I graphed mine and my window is completely off, right? So I'm going to just change that. I don't need negative, right? Negative 10 in the X min. I need to go at least to 70 in the X max. This is where what I want to talk about today, the Y min, because these calculators have a bit of a problem with that. And so I'm going to go all the way to 60 or so on the Y max. There it is. Something isn't right there. Oh, did you see that? I forgot the 5. So that's why, like, check your graph, check when that happens, which happens all the time. You got to be careful. So let's see. This looks more like it. Yeah. So here's the problem. When you go second trace 5, that the writing blocks your graph. That is a problem. With the newer ones, that is not the case. So what you do is you go to Y-min and you decrease it significantly. So I will go, I don't know, minus 40, negative 40 that is, and regraph it. And then it opens up more space down here. So when you're trying to find, right, second trace 5, right, then the writing is here. Okay, so I'm going to find, I need that intersection here. So I'm going to hit enter, and it just jumps to the next line anyway, so that's perfect. And that's 40 and 5. So 45 is the first one that I found. I'm going to find this intersection right here. So second trace 5. And I will, if you go sideways, right, I don't want to be on that line. I want to be on, I'm going to arrow down, jump to that line, and then hit enter. And it automatically goes to Y3, right? Because that's the next one in my queue. So I'm just going to go ahead, enter, and enter. So that intersection is 10, 12.5. Okay, yeah.
Do we round to 13 since this is?
Yes, I will do that in a bit. But for now, I always want you to write down the whole as is, and then next I will round. Good point. And then those are the only two that I need to use my calculator for. This one and this one. This one I already know it's 10, 0. And this one here is 45, 45, 0. So I read this one, I read this one, calc. So calculator ones are going to be worth more on a test than the reading, the ones you can just read off. And because it's discrete, its number of cars can't have 0.5 of a car, right? It's a bit controversial here, but what I do is I just tell students, if it's 0.5, just round it like you would normally do, right? If it's 0.5, 6, 7, 8, 9, right? You just round up. So this particular number rounds to 10, 13. Everything else is good, right? This is good, this is good, this is good. We just had to round the 12.5 to 13. Okay. Why is it controversial? Because technically, as soon as you round up, you're going to be in the false region. But it gets so complicated that I'm okay with that, right? So I teach it that way. That's how we do it, okay? So, okay, we wrote our inequalities. We found the intercepts, we graphed it, we found the POIs. Nothing new, right? This is the last part. Write the objective function relating the profit. So I don't know if you recall, right? There was, if you were following along, you were probably wondering, maybe you were wondering, what is that 750 and the 25 doing there? Isn't there some kind of inequality that relates to that? But if you read carefully, nowhere in the text does it say that the owner wants to make at least this much money, right? You didn't see that anywhere. So in this case, this is for now too much information, right? It didn't really make it onto the graph, right? So, and it is associated with trying to find out how can you maximize profit? How can you make the most out of the situation? So these two coefficients, I'm going to borrow them, take them with me and say that profit, you can choose the letter you like. It doesn't matter. But it's usually a capital letter, and then it's really you're making 750. You can have dollar signs if you want. 750 for every car and $25 for every bus. This is the objective function that relates the profit, not right? Not an inequality, right? Make sure you understand that. Okay. So now, just like we did at the very beginning, right? Remember this exercise here? We took our POIs and ran them through the objective function. We're going to do that again here. Round it, right? So we take 45. We plug that in. I'm okay with you not showing every single step. So if you just do this, you can plug that in later. For now, I'm not going to compute that just yet. So I'm just plugging in 40 and 5. Then I plug in 10 and 13, not 12 and a half.
Wait, where did the 5 come
That is one of my points of intersections up here. Wasn't there a 45?
from? Oh, yeah, that one.
There was one. Phew. I don't want to do this whole thing and get it wrong, Francis. Don't scare me. It's all good. It's all good. Okay, and then it's 750, but I don't have a script right now, so I can be wrong, right? 750, right, and 25, 13. Boom. The next one I have on the list there is, and the order doesn't matter. Just plug them in one after the other. 750 times 10. I will not bother with plugging in the 0 into the y because it's 0, okay? So it's just this. And then 45, 0, the same thing. I just don't want you to think that all examples are the same. It's always going to be like that. The solution region can be anywhere, okay, on your graph. So don't think it always has to look a certain way, okay? Now you grab your calculator and just do what I do. I go 750 times 40 plus 25 times 5, which is 125, right? So you get 425 for the first one. Then, right, this is going to be 75 bucks plus 25 times 13. Right, so that's 400. And this is 75. I know that already. And 75, 750 times 45. That's 337.50. You don't have to have dollar signs yet if you don't want to. So these are the outputs, right? Output. All of these are the various outputs giving it all these points of intersection. So this will maximize, right? In this case, we're interested in maximizing, getting the most out of it. Okay, so here's my statement. Allowing 40 cars and 5 buses will maximize profit. That, ladies and gentlemen, that is optimization, is coming up with an objective function, plugging in your, and the objective function is going to be fairly easy to come up with. Like if it's money, I mean, it's money, right? Like you're going to have coefficients that deal with money in front of them. If it had been time, like some kind of objective function to minimize the time spent on this activity, then you would have minutes and minutes, right? You just look for minutes or hours or whatever. So it is pretty obvious if you're asked to come up with an objective function, just make sure there's no inequality in there. It's just equals, okay? The letter you can choose, P, M, whatever, okay? So there you have it. That's the one there. We're to save ourselves a little bit of writing here. I'm going to ask you to go to the workbook. Go to page 16 in the workbook. 16. Just watch that staple there on page 16, okay? So don't run across it and poke yourself. Page 16. I want you to, right now, just read it. Read this question and come up, like define the variables and come up with the inequalities. Okay, I'm going to wait 5 minutes for you to do that. I want you to read it and come up with inequalities right now. 5 minutos, okay? That's it. Maybe a little bit more. Maybe a little bit more. So just go ahead and do that. Let's see how you did. No, this is the wrong one. There you go. So yeah, they're small business selling pizzas, right? There's the two toppings would be cheese and pepperoni. So I'm sure that most of you, if not all of you, went cheese and pepperoni. We don't know what variables, number of cheeses, right? Number of pepperonis, right? We don't know. So we're going to park that for now. I'm going to make sure that I don't lose half marks, right? And let's see here. So the first one, the first keyword that I see is that a good pizza, right, has to have at least, there's that word, at least 2 times as much cheese compared to pepperoni. So I told you to do it this way. There's many ways of doing that, but you want more cheese than pepperoni, correct? So I'm going to go like this, right? That's for sure. I want more of this than the other one. So where is the 2 going to go? It's going to go on the pepperoni, okay? It's always opposite like that. So that's, if you let this be cheese and that pepperoni, this is what it would look like. If you flipped it, then it would be the other way, okay? I keep reading, right? On average, a pizza has no more than, there's that keyword, that no more than 750 grams of cheese and 250 grams of pepperoni. So we'll talk about cheese no more would be saying up to 750 grams, and y has to be less than or equal to 250 grams. So these are my 3 inequalities present in this case. Okay. I go back to what should cheese and pepperoni have as units? Grams, yes, because, right, if x is less than or equal to 750, it would have to be grams. Yes. What kind of data is that? Discrete or continuous? Anything you can measure, like temperature, mass, distance, is continuous. Okay? Money as well, right? Continuous. Okay? Anything you can measure is continuous. Okay? And so these are my 3 inequalities. I'm going to leave them up to you to graph. How's that? Okay? I want you to get good at writing, and then so this is going to be part of your homework to come up with the graph and everything. You got to be a bit careful because this is all you have in terms of graphing space. So don't use up too much room there. And then you're going to find out the combination that would minimize the cost of producing the pizza. Okay? Let's go to 17. Come up with your inequalities there, please. You need to try this on your own. I will go over it in a bit. See on this one. You can work a total of no more. You're being confronted with that restriction right away. No more than 45 hours a week at your two jobs. So I'm going to say let X be job A and Y be job B. A is pumping gas, right? And Y would be working at the call center. Okay, and I don't know yet what the units are. I'm pretty sure you have figured it out. Some of you have. So we just make sure that X and Y will be greater than or equal to 0. And I'm looking at no more than 45 hours between the two jobs. So I can't help but think that if I combine the hours worked at both, that has to be less than or equal to 45. Then I go up and say, you know what, this is going to be in hours and hours, right? I'm confronted with that right away. It only makes sense to read it if you know that it's number of hours. And then you're getting paid $12.50 at the gas station and $14.25 at the call center. But you need to earn at least, right? You want to earn at least $345. So there's a dollar amount. So you're going to use the dollar coefficients, right? Like so. And this combination, right, that you're going to be working, you want that to be greater than 345, right? At least $345 to be earned there. You keep reading. The outbound call center allows you to work less than 20 hours per week, right? So call center, it's less than 20 hours per week. So you want to translate that to the number of hours at the call center have to be less than 20 hours. Did you catch the less than? It's not less than or equal to. This is the one example that has a dashed line. I just threw that in there. Okay. I will be honest that you probably, like on a test and stuff, you won't have to worry about it. In fact, it makes it very complicated if it can't be when you're finding the point of intersection. So treat it as if it's a solid line when you're working with it. I just wanted you to read it and pay attention to that. So these are your three inequalities. Easy peasy, right? Easy. This one is maybe a little bit more work to graph, right? And so hold on, not yet. Don't pack just yet. I want to talk about the objective function. It says you're gonna graph, you're gonna find the POIs, that's you. Write the objective function to calculate the total income. What would that objective function look like? Yeah. Equals profit. So yes, you can go equals profit here. My key most of the time, or you can call it capital I, or you can call it whatever you want, really. But yes, that's the objective function. Yes. So this is your homework. Hold on. Make sure you write this down because I will AC you 16 and 17, sorry. So you're going to do the graph and all of that. And if you want to get ready for tomorrow, page 20. I'm not saying that's going to be all, but make sure you do these two and page 20. You're learning how to graph, which I'm going to make you do tomorrow. The objective function is not going to be on there, okay? Thank you, guys.